Hi everyone. By the end of this video, you will have a clear idea on position time graph, and slope of position time graph gives you velocity. Velocity time graph and slope of velocity time graph gives you acceleration. Area under velocity time graph gives you displacement. Then instantaneous velocity, its derivation. Equations of motion, derivation using graphs, and as usual, some MCQs, ARQs, and numericals. To begin with, distance time graph. What does that mean? Distance time graph means distance on y-axis, which is in meter, time on x-axis, which is in second. And look at the green line, it's the graph. And you can see from the graph, as time increases, distance also increases. Now, what does slope of distance time graph gives? In math, slope means tan theta. Tan theta means opposite divided by adjacent. Opposite, we call it as, in physics, vertical rise, and adjacent means the horizontal run. So one form, rise over run. And rise on vertical axis is distance, and run on x-axis is time. So eventually, slope becomes distance divided by time, and distance divided by time gives you speed. So slope of distance time graph gives you speed. Now, moving on to another graph, displacement time graph. Slope of displacement time graph means displacement divided by time. On y-axis position and on x-axis time. As I said before, slope means rise over run, which is change in position, which is displacement, divided by run is time, and we know displacement divided by time gives you velocity. So slope of position time graph means displacement divided by time, velocity. Now, let's do a question. They wanted to calculate velocity from position time graph, and we know slope means displacement divided by time, which gives you velocity. Let's find the slope. Slope is rise over run. Look at the rise. The graph starts from 0. The vertical rise is until 4. So the rise will be 4, take away 0. And the horizontal run, you can see, starts from 0 till 4. So the run is 4 take away 0, which eventually gives you 1 meter per second. Key point, all the way, since it is a straight line, the slope is giving you a value 1 meter per second, which means the car is moving with constant velocity from start till 4 seconds. And let's find slope for the second part of the graph. You can see slope is again rise over run, but you can see it is not a rise, it's a fall. So the fall is from 4 to 0. So I'm writing 4 to 0. Run is from 8 to 4. So 8 take away 4. Eventually, it gives you 1. The minus sign shows it is not a rise, it is a fall. So second part of the journey, from 4 seconds to 8 seconds, the velocity is just minus 1 meter per second, which means it was moving right initially, and there the velocity changes. It goes back because of minus sign. So remember, at 4 seconds, the velocity is 0. From 0 to 4, velocity is positive 1, which is moving to the right. And at 4, the car, if it is stops and then it goes back. Why is it going back? You can see the velocity is minus. Now, let's interpret the position time graph. Look at this. For the first part of the journey, from 0 to 3 seconds, you can see position doesn't change. Position doesn't change means it is not moving, which means the car is at rest from 0 to 3 seconds. And thereafter, you can see a straight line, and you can see the position changes from 0 to 4, which means it's moving. But remember, being a straight line, it is moving with a constant velocity. Another way, uniform motion from 3 seconds to 6 seconds. Another graph, let's see. The first graph, position time, simple. You can see from the graph, the position increases gradually, which means it's moving with a constant velocity, but you can see positive slope. So it's moving with constant positive velocity. Look at the second part of the graph. You can see position decreases gradually with respect to time, which means again slope is a constant. Since it is a fall, it's a negative velocity. So position decreases with the time and it's moving with a constant velocity but negative. Constant positive velocity for the first part, constant negative velocity for the second part. And look at the third graph. You can see here the position doesn't change. Slope is 0. So velocity is 0. The body is at rest. Now, another graph. Look at this graph. You can see constant slope. So until 2 seconds, it's moving with a constant velocity, uniform motion. And thereafter, you can see the slope of the graph changes. You can see slope increases and then decreases. Steepness of the graph increases and then decreases. So slope increases and then decreases for this part. And we know slope is velocity. So velocity increases first until here maximum velocity and then decreases, which means velocity is not constant, non-uniform. For the second part, from 2 seconds to 5 seconds, it's moving with non-uniform velocity. And for the last part, look at this part, horizontal line, slope is 0. So it's not moving, velocity is 0. Let's do some MCQs. Slope of position time graph means position divided by time, which is velocity. Second one, slope of distance time graph, distance divided by time, which is speed. We move on to difference between average speed and average velocity. We knew average speed means total distance traveled divided by total time, which we call it as total distance traveled in unit time. And for the velocity, it is total displacement divided by total time, which means total displacement in unit time. Now, let's see the difference between instantaneous speed and instantaneous velocity. Speed is a scalar, velocity is a vector. And what is the meaning of instantaneous speed? Instantaneous means at a specific time. So, speed of an object at a specific time, we call it as instantaneous speed. To get the instantaneous speed, you have to find the average speed for the whole journey and then you make the time duration very close to 0. What I said is average speed becomes instantaneous speed when the time gap approaches to 0. Not equal to 0, but approaches to 0. Now let's see instantaneous velocity. Same way, velocity of the object at a specific instant of time. And how do we get it? First, go for average velocity, then make the time interval very close to 0, but not equal to 0. Changing my wordings, average velocity becomes instantaneous velocity when the time interval becomes 0. Now, how will you find the instantaneous velocity of a car? In case of a car, the speedometer gives you instantaneous speed or instantaneous velocity if it specifies the direction. Now, how do we calculate the instantaneous speed or instantaneous velocity? We know the average velocity is total displacement divided by total time. Normally, total displacement we choose with the letter delta x, total time interval delta t. And I told you the average velocity becomes instantaneous velocity when the time interval approaches to 0, becomes so close to 0, not equal to 0. Then we know displacement also becomes very close to 0, but not 0. And by the rule, so what I said is delta x doesn't become 0, delta t also doesn't become 0. If it becomes 0, you can see here divided by 0 is meaningless. So it is with a proper meaning that delta t is not 0, then delta x divided by delta t has a finite value, not infinite. Why? When delta t becomes 0, you know by math this becomes infinite. No, in this situation, delta t is not becoming 0, it becomes close to 0 so that we have a finite value. So what I said, the average velocity becomes instantaneous velocity when we apply the limiting value. What is the limiting value? Delta t approaches to 0. Mathematically, we write like this. And delta x divided by delta t. In math, what we call this as d divided by dt. This is a new operation in mathematics. Dx divided by dt. What we call it as differential coefficient of position vector. So how do we find the instantaneous velocity? We have to differentiate position coordinate to get velocity. Now, just I want to tell you the difference between average velocity and instantaneous velocity. Remember, average velocity for the whole journey, total displacement divided by total time. It doesn't tell you any details of the motion. It talks to you for the whole journey. But instantaneous velocity gives you how fast the car is moving at each instant of time. You remember, like speedometer. And how do you calculate it? You have to differentiate. This is a new mathematical operation. What is x? Position. So if you differentiate position, which is a mathematical operation, you get instantaneous velocity. Let's do some MCQs. The first MCQ, dash tells you how fast a particle is moving at a particular instant of time. It doesn't talk about direction. So it is not velocity. It is instantaneous speed. So the answer is instantaneous speed. Next question, how fast a particle is moving in a particular direction. So it is talking about direction. So it is instantaneous velocity. Which one has all the details of the motion of a particle? It gives only the result of the motion. You remember, it is not instantaneous. It is the average speed because it doesn't talk about direction. We move on to assertion reason questions. The first assertion, speedometer of the car gives instantaneous speed of a vehicle. It is not instantaneous velocity, which is true. Average speed is always equal to instantaneous speed of a moving object, regardless. Oh no, it's wrong. So reason is false. Assertion is true. So the answer is C. Next, the magnitude of instantaneous velocity of a particle is always exactly equal to instantaneous speed. Yes, because the magnitude means no direction. So assertion is true. Now let's read reason over an infinitesimally small time interval, which means the time gap becomes close to 0, not 0. Then we know distance traveled by the particle is equal to the magnitude of the displacement, which means for a small duration, it doesn't travel a distance. We know delta x is also close to 0, which means when delta x becomes close to 0, distance and displacement are equal. So that is also true. Now, reason, is it the correct explanation? Yes. Instantaneous velocity becomes instantaneous speed. Why? At that instant, distance traveled becomes equal to displacement. What do you mean by at that distance? So reason is the correct explanation for the assertion. So A is the correct answer. Another assertion reason questions. It is entirely possible for a moving object to have an average velocity 0 or for a specific time interval. If it comes back, this is possible. But average velocity for the same time interval is not 0. True. Average velocity depends on the net displacement. True. Which becomes 0 when the object returns. True. Whereas average speed depends on total length of the path, which continues to accumulate, which means which gets added on as you travel. So this is also true, and this is the real reason for the assertion. So the answer is A. Number 4, the magnitude of average velocity can never be greater than the average speed of any given time interval. True. The reason for that is displacement is always the shortest, smaller than distance. So average velocity will be smaller than the average speed. True. And reason, instantaneous velocity is mathematically defined as rate of change of position. That is also true, which is given by true. Both of them are true, but reason is not the correct explanation. The correct explanation for the assertion is average velocity is smaller because displacement is always smaller than the total distance traveled. So assertion is true. Reason is also true, but reason is not the correct explanation. Now, number 5, the direction of instantaneous velocity of a particle is always tangent to its path. That is true, tangential. To get instantaneous velocity, time interval has to approach zero. Displacement vector is always tangential to the trajectory. That is also true, and that is a real explanation why displacement is tangential. So instantaneous velocity will also be tangential. So correct answer is A. Now, sixth one, the instantaneous velocity of a particle moving in one dimension can be negative, but instantaneous speed is always positive or zero. Assertion is true. Positive means if it is moving right, instantaneous velocity can be positive. If it is moving left, instantaneous velocity can be negative. Now, instantaneous speed is the time derivative of displacement. No, instantaneous velocity is time derivative of displacement. So reason is false. So the correct choice is C. That's all. Thank you so much.